Last topic is the Muller's method. Muller's method is used to solve three roots for equation. For solving the Muller's method, we need this equation that is derived from the concept of Muller's method. So obviously delta 0 and delta 1 is just a 2-point form slope, and h0 and h1 is just the distance of the points. So for the equation of the coefficients, a is equal to delta 1 minus delta 0 over h1 minus h0. b is equal to a times h1 plus delta 1, and c is basically equal to f of x2. So we have x sub 3 here. X sub 3 determines the next value of our x sub 2. So we need to assume a value of the roots for this equation. So we use negative 1, 6, 4. Then we need to substitute negative 1, the function of x, that will give the value of negative 2. 6, the function of x, that yields 189. 4, the function of x, that yields 35. So using the equation here, our delta 0 is equal to 26.71. Delta 1 is equal to 77. h0 is equal to 7. And h1 is equal to negative 2. For a, using the equation delta 1 minus delta 0 over h1 plus h0, we have the value of 77 minus 26.71 over negative 2 plus 7 equals 10.05. So for the value of b, 10.05 times negative 2 plus 77 equals 56.9. So for the value of c, basically the value of f of x2, which is 35. So for determining x3, take note that we have three coefficients here, meaning we need to use quadratic equation. So inside the equation of the quadratic equation, we have the discriminant. Notice that discriminant must be added to the value of b. Your b must be, the discriminant must be near to the value of b in order to determine that you are solving the right steps of the Muller's method. So discriminant b squared minus 4ac, 56.9 squared minus 4 times 10.05 times 35 equals 42.78. So substituting it here to the equation, x sub 3 is equal to 6 plus negative 2 times c, 35, over b, which is 56.9, and your d, which is 42.78, have the value of 5.29. So your 5.29 is the next x sub 2, and your x sub 1 and your x sub 2 is your next x sub 1. X sub 1 is the next x sub 0, 6. So substituting 5.29 to the function of x will give the value of 119.40. So substituting again the values before from the x1 and x2 and your 5.29 to delta 0, delta 1, h0, and h1, you have the value of 77, 65.42, negative 2, and 1.29. So for a, solving the value of a, we have 65.42 minus 77 over 1.29 plus 2 equals 16.3. Then we have the value of b as 86.44. the value of C of 5.29. So, solving the value of x3 using the discriminant again, we'll have the value of 3.91. So, determining the margin of error, EA is equal to 5.29 minus 3.91 over 3.91 times 100 equals 5.29 minus 3.91 over 3.91 is equal to 35.29% of error. So continuing to this, the solving of this problem, 3.91 is the next, like sub 2, 3.91, 5.29, and 4. So for solving this 3.91, substitute the function of x will give you the value of 31.77. So again, substituting the values we have to the equations of delta 0, delta 1, and h0 and h1, we have the value of delta 0 of 1.29, negative 1.36, for delta 0, 65.42, delta 1, 64.43, h0 is 1.29, and h1 is equal to negative 1.36. For A, 14.11 using the equation, and B, 14.14, B, 45.19, 45.19, and 3.93, 3.93 for C. Just 3.93, 3.93. Then, for x3, we have solving the values of x3 using the equation here, and using the discriminant, we have the value of 5.2. So before we have the margin of error of 35.29. Now, using the equation 3.93 minus 5.2 over 5.2 times 100 3.93 minus 5.2 over 5.2